Okay. Okay, how many questions do we have? You guys are so funny. Is this? No, it really is April 1st. Right? For a minute, I thought I had to do lots of problems on the board.
Wait, actually.
Oh my god. Just say it. Just say it.
Say what?
April 1st?
Say it.
What? Is this April 1st? Okay, we're doing 4 and 5. Is that what we're doing? Okay. Oh, we need chalk. Okay, number 2B. Are you choking me? Wait, how can we do 2B but not, 2A but not 2B? That's just the way we are. A standard die is rolled 4 times. What is the probability of rolling at least 2 ones? Now, what does that mean, at least 2 ones? Yeah, so 2, 3, or 4 ones, right? So then you gotta think, is it better to compute it directly, or should I go with the complement and subtract from 1? Now, what's the complement of at least 2 ones? 1 or 0. So either way, you're gonna have to do 3 computations, right? Because if you do the complement 0 or 1, then you still gotta subtract from 1, which some of you have problems with, I noticed. Because you guys don't like to borrow. So which one do you wanna do? Just compute it directly. Okay, let's do it directly. So 2 ones, 3 ones, or 4 ones. Those are the 3 cases you need to make. Okay, so if I roll a die 4 times, what is n? N is 4. This is the number of successes you want. What's the probability of a success? If you roll a die, what's the probability of rolling a 1? 1, 6. So therefore the probability of a failure is going to be 5, 6 then, right? So what's the probability of getting exactly 2 ones? Using the formula we learned? 4 choose 2, probability of a success to the 2, probability of a failure to the 2, right? Next case, 3 ones. So we're going to play the period 3 game. We're going to play the period 3 game then. 4 choose 3, 1 6 to the 3, 5 6 to the 1. And then finally 4 ones.
4 choose 4.
No. Don't say anything. Just sit there. Just sit there like soccer. And there you go. You write that on your paper. You get 3 out of 4 points. You want the last point, you got to compute it. Okay, number 3, B and A. Thank you for putting it in alphabetical order. 3A. A basketball player's free throw percentage is 75%. So what does that mean? The probability of a success is 3/4. Therefore, the probability of failure is 1/4. Find the probability that she will make 4 of her next 5 free throws. So what is n? Yeah, you're going to do it 5 times, and we want 4 successes. So 5 choose 4, 3/4 to the 4, 1/4 to the 1. These 2 powers people have to add up to 5, just like the binomial theorem. That's why they call this binomial probability. And then in part B, at least 3 of her next 5 free throws. So what does at least 3 mean? 3, 4, or 5, or you want to do the complement, 2, 1, and 0, subtract that from 1. That is ludicrous, right? So I think in this case we'll do 3, 4, 5. What's the probability of making 3 free throws if you shoot 5? 5 choose 3, probability of success to the 3rd. Whatever number's down there, that's what you put up there. You teach my dog that. Whoop, whoop. 1/4 to the 2, plus 4 free throws. 5 choose 4, 3/4 to the 4, 1/4 to the 1, and then 5 free throws. 5 choose 5, 3/4 to the 5, 1/4 to the 0. Okay, tell me, where are we going wrong here?
Wait, what is the 5 choose 3 one to be? Because when I added them, they came out to be more.
Okay, 5 choose 3 is the same thing as 5 choose 2, which is 5 times 4 over 2 times 1, 10.
I forgot to divide by two.
Paper first.
How many times have you choose? And then 4. We're doing everything. A quiz has 10 multiple choice questions, each with 4 choices. If you guess at each question, find the probability of getting all 10 correct. So, we're doing it 10 times. What's the probability of success? 1/4. What's the probability of failure? 3/4. And then we want 10 successes. So, 10 choose 10. 1/4 to the 10. Move on. 3/4 to the 0. And what happened with that one? 4 to the 10? Well, look at the answer on the bottom. Where's the answer? 1 over
Oh my god.
10 million, no. 1, that's only 1 million, it's less than 10 million. I don't see a problem. And then B, are we doing the whole thing? Okay, don't answer me. B, at least 1 correct. So that one, we definitely want to do the complement. Okay, what's the complement of at least 1 correct?
None.
None correct. So what's the probability of getting none correct? 10 choose 0, 1/4 to the 0, 3/4 to the 10, and then you're going to subtract that from 1. Now, if you want to use your calculator on these problems, that's fine. If you want to be a weakling, go right ahead. Go ahead, make my day. But then what's going to happen on the test? Pain! That's what's going to happen. And then what about 5 correct? You want 5 successes, so what? 10 choose 5, 1/4 to the 5, 3/4 to the 5. Are we getting the hang of this? I don't believe you, but whatever. And then finally, number 5. That's okay, this is a good class to ask all the questions, that way we got on a video, right Morris? What are you doing? Playing with your phone?
No, calculator. Play with
Oh, that was a quick switch. Oh man, I don't know how you did it.
Magician.
A coin is tossed 5 times. Find the probability of obtaining 3 tails. So we're gonna toss the coin 5 times. The probability of a success is 1/2, therefore the probability of failure is 1/2, and we want 3 successes. So what? 5 choose 3, 1/2 to the 3, 1/2 to the 2. I don't like it when these two numbers are the same, right? Don't worry, tomorrow it'll be different. And then B, a coin is tossed 10 times. Find the probability of getting 6 tails. So now n equals 10, and then these are the same. So 10 choose, how many successes do we want? 6, 1/2 to the 6, 1/2 to the 4, because the 2 powers gotta add up to 10. And then see, which one is more likely to occur? Now see, if you think about it, you toss a coin 5 times, what's the probability of getting 3 tails? Oh, whatever it is. But then you toss a coin 10 times, what's the probability of getting 6 tails? And then a lot of people might think, shouldn't it be the same? Because 3/5 is the same thing as 6/10, right? But it's not. That's why I put this problem on there, and that's why the answer for C is duh. Duh. Huh? And notice how I made a least common denominator so you can like compare. Why is this one more likely than that one? Shouldn't they be the same?
Less chances for failure.
What? What? Why is this bigger than that? Okay, you know what? I'm not gonna. Maybe I'll ask you that on the test.
Oh.
No.
Explain in your own words why this one is more likely than that one.
You don't do it.
Maybe then you'll speak up.
Don't do it.
Okay, we're moving on to probability 5. Now this is, in fact, you know what? Look, you only get 5 5 problems on tonight's homework, look at it.
They're really long.
But it got a lot of words. I don't like reading words. Okay, you know what? I'm gonna do one of the I'm gonna do 1A for you. Anyway, did anybody look at the examples that I... Do you guys even look at the examples that I spent hours and hours making? Some of you still don't even know there's examples there, yeah? It's the 4th quarter. Okay, let's look at problem 1A. You read silently while I read aloud. Jar A contains 1 red ball and 2 white balls. Jar B contains 2 red balls and 2 white balls. Jar C contains 3 red balls and 1 white ball. A die is rolled. If an even number comes up, a ball is randomly picked from jar A. If a 1 or a 3 comes up, a ball is randomly drawn from jar B. And if a 5 comes up, a ball is randomly picked from jar C. I'm only going to do A for you. So here's problem A. If a red ball is picked, what is the probability that it came from jar A? What? Say what, girlfriend? If a red ball is picked, what's the probability it came from jar A? What the heck is this? This is not your normal probability problem. This is what we call conditional probability. This is what separates the goat from the sheep. You pass this note up. Very good, look. There's an example right there.
Yeah, probability tree.
Probability tree.
Yeah, exactly.
Okay, so let's go back to the very first day we did probability.
Sorry, I this.
I guess it's not crinkling. You guys remember this? The probability of event A. Did I tell you when I went to Las Vegas about the crinkling?
No.
I was in Las Vegas during spring break and we went to see Jersey Boys. You guys seen that? That's awesome. Anyway, we're sitting down in our seats, which cost $100 each, by the way. And then in the back over here, people come late. The show already started. They come late. Like, except it's like the, you know, the cellophane wrap, so it's like really loud. There's like 3 seats down, right in the row behind me. And then on this side, a person is eating peanuts out of a bag. I had it in stereo. It was perfect. An enjoyable experience. I can't believe the person like right in front, they didn't look back and give him the eye or something. Anyway, what is this equal to? Love. We did this on the very first day. What is the probability of events A and B occurring? I wrote it on the board. Plus it's in your notes.
Oh, PA.
The probability of A times,
Probability of B. I mean, yeah, right.
so N, that's it.
B.
No, B.
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 After A. B.
Knowing that A already occurred.
B occurred.
But, and then what would happen if the 2 events are, what do you call it when one doesn't affect the outcome of the other?
Independent.
Independent. If 2 events are isn't that the same thing you said the last time? I think so. Yeah, no, you did. If 2 events are independent, that means one doesn't affect the outcome of the other, then the probability of A and B occurring is equal to the probability of A times the probability of B. But if one affects the outcome of the other, then you use this one, right? Remember that? Is it all coming back like a bad dream now? So in the problem that we're doing over here, it says, if a red ball is picked, what's the probability it came from jar A? See, everything depends on what happened first, right? That's why we're going to use this one right here. So this is the one we're going to use. And what are we trying to find? This is the thing we're trying to find right here. See, if a red ball is picked, what's the probability it came from jar A? What's the probability that the ball came from jar A, knowing that a red ball was picked. So this is the thing we're trying to compute in this problem. So, arranging this this equation around, the probability of B knowing that A already occurred is equal to what? Can you divide both sides by probability? Probability of A and B occurring divided by the probability of A. So the P's cancel, the left parentheses cancel, the right parentheses cancel, the A's cancel, so all you get left is and B.
No. No.
April Fools. Okay, so tonight when you do your homework, this is what you're going to use every single problem. But the hard part for you is you got to read the words and translate it to this. Okay? So here we go. Now I had a 400 SAT verbal. I can understand this. So you guys are all above this, right? So I think you can figure this out. If a red ball is picked, see, but that was good enough to get into UH. I told you this before, right? Okay, back in the old days, there was only 2 parts to the SAT. You just had the verbal and the math, but now you have writing, yeah? Anyway, back in the old days, to get into UH, you just needed a 1,000 combined. So 400 verbal, 600 math, I'm in. Anyway, here we go. If a red ball is picked, what is the probability that it came from jar A? So what are we trying to find? What's the probability that the ball came from jar A, knowing the red ball was picked? You have to be able to translate that sentence into this. Can you guys do that? Yes or no?
No.
Height or EA?
Height.
You guys understand it though? If a red ball is picked, what is the probability that it came from jar A? You want me to boil it down for you? Just like first grade? Okay, look at this sentence. If a red ball is picked, what is the probability that it came from jar A? So whatever comes after, what is the probability that blank? That's what goes there. Do I really have to boil it down like that? And then if a red ball is picked, whatever comes after the if goes here. Because that's kind of what this means. It kind of means if. Knowing that. Okay, and according to this theorem, what is this equal to? Every year we go to the same thing. Okay, you see this B. No. You see this B. Where you put that there. You see this A. You put it here and here. So this is equal to the probability of
Red.
the ball is red and
Jar.
it came from jar A divided by the probability that the ball is red. Are we following? But Mr. Park, how do I figure out these things? Well, to figure out these things, well, Lum already said it. You draw a probability tree. You draw a probability tree, you can answer all of these questions easy. Okay, now, what's going on here? What's the first thing that happens in this?
You roll the die.
You roll the die. Okay? If an even number comes up, then you pick a ball from jar A. If a 1 or a 3 comes up, you pick the ball from jar B. If a 5 comes up, you pick the ball from jar C. So how many, if I roll the die, how many things can happen?
3.
3, or is it 6?
3.
Okay, 3. So what you do is you make 3 branches of that. And what are the 3 branches? It's even. What? Even. Yeah, I guess that's the kind of same thing, right? Then a 1 or a 3, and then a 5. Okay, then what you need to do is put the probabilities of each event happening now. If I roll a die, what's the probability of rolling an even number?
1.
3 out of 6. Okay, I'll just leave it 3 out of 6. What about a 1 or a 3?
1/3.
And then what about a 5?
1.
Okay, see how easy? Okay, but if you roll an even number, you're going to pull a ball out of jar A. Now, what can happen when you pull a ball out of jar A? It's either red or white. Are you guys following? You guys drew trees like this in when did you do this? Pre-algebra? You guys don't remember.
8th grade.
Thank you. That's algebra 1. I don't think you do probability in algebra 1. I think you do it in pre-algebra.
Mine.
Did you guys do statistics in the pre-algebra? Remember box and whisker plot? Does that sound familiar?
I remember the
How
ball.
come you can remember that? Because it has a cute name. It has an whisker. Anyway, what's the probability of pulling out a red or a white ball? What's in jar A? Red is 1/3, 2/3, correct? Now what happens if you roll a 1 or a 3? Then you're gonna pull a ball out of jar B, and it's either gonna be red or white. And what's the probability of these things happening?
1/2, 1/2.
1/2, 1/2. Okay, and then what about from jar C? It's either gonna be red or white. What's the probability of these things happening? 3/4, it's 1/4. This is called a probability tree. Once you draw this tree, now after a while, come on, we're honors, right? You don't even have to make the tree, right? But if you get something wrong and I don't see the tree there, fatal error. Okay, here we go. What is the probability that the ball is red and it came from jar A? So what branches correspond to that? The ball is red and it came from jar A.
Even
Right here, you roll it even, because if you roll it even, you're gonna pick it out of jar A, and the ball is red. So what's the probability that you rolled an even number and then you pulled out a red ball? 3/6 times 1/3. How come I multiplied it?
So it's and.
Yeah, because and implies multiply or implies addition. And then you have to divide that by the probability that the ball was red. But isn't there 3 ways the ball could have been red?
Yes.
Right? You could have pulled a ball out of jar A and then pulled out the red ball, right? So what's the probability of that happening? 3/6 times 1/3, which is of course the same thing as that. Plus, what's another way you pulled out a red ball? You could have pulled it out of jar B and then pulled out the red ball. So what's that? 2/6 times 1/2. And then what's another way you could have gotten a red ball? Roll the 5 and then you pull out the red ball from jar C. And what's the probability of that happening? 1/6 times 3/4. Boom, that's your answer. Now, you're only gonna get one problem like this on the test. It's probably gonna be worth 8 points, so you write that down, that's 7 out of 8. You want the last point? You gotta compute it. What's the fastest way to compute like complex fractions when you have fractions and with fractions? Because some of you still have computation issues. Multiply top and bottom by the least common denominator. Now, I don't know what you wanna do. You wanna like simplify each fraction before we begin? Okay, whatever. Okay, so the top one is 1/6, and then what do we got? 1/6 plus 1/6 plus 1/8. Did I do that correctly? Of course, I'm the teacher. So what's the least common denominator of 6, 6, 6, and 8? 24. So multiply top and bottom by 24. 4 over 4 plus 4 plus 3, 4 11ths. So every single problem is exactly like that, but you gotta sift through the information. So first step, you gotta be able to translate that into this. I showed you guys how, right? Step by step. And then once you do this, you just make the probability tree and you can answer the question. The only difference, the only thing that can make it harder is that you just have more branches in the tree. Like this one only had 3 to begin with, right? Who knows, you might have like 4. And then in the next layer might have, each one might have 5. Right, but it's the same concept, right? Or is all hell gonna break loose? This is how, remember I told you, didn't I tell you next week we're gonna video the class? Is this what's gonna happen? I can expect this.
Wait, we're not gonna, what do you mean?
Next week during extended, we're gonna have our regular lesson, and then I need to reshoot. You know the lecture we had, the second lecture we had on parametric equations. Because what we caught on the video wasn't good enough, so we gotta like re-video. So what's gonna happen? We're gonna do like the original lecture first, and then we're gonna do the graphic calculator stuff I told you guys to do. And then I need to come around and like remember I was practicing shooting like this? Then I need to come around and I need to see your faces.
Like this glaze in the background.
Well, that's good. That'll be hilarious. I won't win the award, but it'll be hilarious. Okay, we're done. So I already told you what's on tomorrow's quiz?
No. Oh, you said 2 problems
No,
that
there's
are
5.
binomial problems.
Okay, 2 binomial problems.
And then
And 3 okay, one's a card problem. Okay, you wanna just do one for fun, just so we get back, we have time?
Yeah.
Okay, card problem.
Okay.
Okay, I'm going to randomly select 5 cards from the deck. Okay, now the way I want you to do it tomorrow is you pick all 5 at once. However, if you do it one at a time, that's fine too, because it's correct, right? Okay, so what's the denominator gonna be? You have a standard deck of 52 cards, I want to randomly select 5.
52 choose
Okay, 52, choose 5. And of course, math team people got it memorized already. We're done. Remember I told you guys to memorize this number? Why? Anybody? Morris? 2,598,960. It's common knowledge. Okay, what's the probability? What did we do? We did an example last time. What was it? Did we do full house last time? I think we did full. Let's do something different. What do you want? 2 pair, 1 pair, what? Pick one. Okay, 2 pair. Oh, you guys saw the cleats there. Okay, now there's people in the class, they don't know the poker hand, so then I give example, yeah? So what we're trying to find the probability of getting 2 distinct pairs. You know what that means?
Different.
Yeah, so like if you get 4 aces, that's not 2 pair. No, there's people who think that. Okay, so 2 distinct pairs. So for example, you have 2 jacks, 2 sevens, and another card that's not a jack or a 7.
Yeah.
Because if it were a jack or a 7, it would be a full house. So I would define what it is. It's like, who's the person in period 3 that doesn't know how to play cards?
Chai.
That's period 4.
Chai. Ricky Chai.
Come on. No, it's a girl.
Sita.
Shuko. Wait, no.
No, Zhang. Oh, so she's lying then. She knows how to play cards.
No. What would be
Protecting her. Okay, so remember, do a specific case. But here is the, like I gave you the specific case. So how many jacks are in the deck?
4.
How many ways can I pick 2 of them?
4.
How many sevens are in the deck?
4 choose 2.
That's, you're not answering the question. 4. How many ways can I pick 2 of them? How many cards in the deck are not jacks or sevens?
52 minus 8.
44. How many ways can I pick 1 of them?
44.
44, choose 1. See, that accounts for all 5 cards, right? Now, this is the most important part. Now you gotta multiply by the number of cases. This is just a case where you have a pair of jacks and a pair of sevens. What about queens and 3s, or aces and 4s, or 9s and 8s, or 2s and 7s?
13 choose 2.
13, choose 2. Do you guys understand that? Are you sure?
Yes.
How come you guys keep on getting it wrong? Okay, so tomorrow you write that down on your paper, you get 3 out of 4 points, and you want the final point, then you gotta compute this thing. Anyway, it's not beneficial to memorize 2,598,900, right? Because you wanna write out all the factors and start canceling like a mad dog, right? You know what I'm talking? Look, what is 4 choose 2?
4
Over. Okay, what is 4 choose 2? What's 44 choose 1? What is 13 choose 2?
13 times 6.
Okay, all over 52 choose 2, which is 52 times 51 times 50 times 49 times 48, all over 5, 4, 3, 2, 1, but the 5, 4, 3, 2, 1 goes on the top, right? When you divide by a fraction, that's like multiplying by the reciprocal. And then let the canceling begin. And you guys know already, look, 13 times 4 is 52. 3 goes into 51 17 times, right? No, if you've been doing your homework, you do that automatically already, right? Those of you who don't do your homework, you're just wondering, yeah? Continuing on, what else can I do?
6 and 48.
6, 2, 48.
Six.
So
5 and 2 is 10, goes into 55 times.
48 and 6.
6 goes into 48 8 times.
44 and 8.
44 and 8.
What? 44 and 8?
Divide by 4.
Divide by 2. Why not divide by 4? 4, but 2 can go into 6 3 times.
I guess I can see.
What? This is arithmetic. So all you gotta do, you wanna go 66 times 3, or you wanna go 18 times 11, or you got 33 times 6?
198.
Times 11.
Okay, what's 66 times 3? 192. Can do. All over. Now, what do you want to do? You want to go 85 times 49, or you want to go 245 times 17, or you want to go that times 5?
It's 198.
What?
698.
Oh, yeah, 198. It is. All okay, now you can do it then. So shall we go 85 times 49? 85 times 49, 5 carry the 4, 0 carry the 2, so 5, 6, 1, 4. So 4, 1, 6, 5, cancel the 1s. No, that's it. Can we do that tomorrow? What if I dumb it down and go 4 card hand?
Yeah.
3 card hand.
2 card, 1 card hand. Probability of getting a pair.
0.
Example, 2 aces. Okay, no, yeah, you can take that. Yeah, the bell rings in 1 minute. So tomorrow is the last lecture. So tomorrow's lecture is what happens when we involve money with a game of chance. That's called gambling. So when you play a game of chance involving money, what are you expected to win or lose every time you play the game? Yep, that's expensive.
Or you learn how to count cards.
No. I think you can teach yourself that, right?